So here we are asked to divide the complex number 5 minus 3i by another complex number, 4 plus 3i. And in addition, we then want to take our simplified answer and rewrite this as a plus bi, the standard form. So to get us started here, let's simply begin by rewriting this rewriting this statement as a quotient. So here we have 5 minus 3i, all divided by 4 plus 3i. Now, at this point, we're kind of stuck. We can't simplify any further, but we know we want to achieve this complex form. So in order to do that, we want to take a look at the binomial in our denominator and multiply it by its complex conjugate. So we'll take our ratio here, and we're going to multiply the numerator and denominator of this by the conjugate of the denominator. So in other words, we're multiplying the numerator and denominator by 4 minus 3i, all divided by 4 minus 3i. So the binomial looks the same as the denominator of our expression, but the signs have changed. And now we can go ahead and rewrite this as a single rational expression, 5 minus 3i multiplied by 4 minus 3i. And this is all divided by the product of complex conjugates, 4 plus 3i multiplied by 4 minus 3i. Now, we'll keep in mind here that the product of these complex conjugates should produce a real number. So that's going to be a great way for us to check our work. But in the meantime, we've got a lot of expansion to do. So doing the FOIL method in our numerator, this leaves us with the expression we have 20 minus 15i minus 12i plus 9i squared. And very similarly, we need to apply the FOIL method to the binomial product in the denominator. So here this is going to leave us with 16 minus 12i plus 12i minus 9i squared. Now lots of simplification is going on here. In the numerator, we can see that we have these two like terms, or two constant terms that need to be simplified. We also see the I squared, which we know I squared is equal to -1. In the denominator, we have similar case where our two intermediate terms are like terms, but here they're going to cancel each other out. And again, we see that we have our I term squared. So simplifying the numerator, again, we can combine -15 and -12 to give us 20 minus 27i plus 9 multiplied by -1. And in the denominator, we are left with 16 minus 9 multiplied by -1. So we can simplify a little bit further here. 20. I'm going to bring this 9 times -1, my constant term, over next to 20, since these are like terms. And then we're still going to subtract that minus 27i. And in the denominator, we can see we have -9 times -1. So this is going to become 16 plus 9, which combines up to 25. So last but not least, combining our two constant terms, we're left with 11 minus 27i, all divided by 25. So hooray, our denominator is in fact a real number, but we're not done yet. Remember that we want to write our final answer in the standard complex number form. So in order to do that, we need to take our denominator here and distribute it through each of the terms in our numerator, allowing us to achieve our beautiful final answer of 11/25 minus 27/25 times the number I.